And I think this might be developing into something really interesting. Hey, it's Marek. Uh, I have a story for you. Imagine Poland, 1980s, mid 1980s, 1985, maybe 1984, perhaps 1983. Poland is behind the Iron Curtain back then, under massive influence of Soviet Union. Some would say that it was occupied by the Soviet Union. I was a young kid, preschool age. We were visiting family in another town, November, gloomy, rainy. We walk into this multi-family building to the apartment where my uncle used to live in. Um, and I walk in, a young kid, and I look inside, and in the middle of the living room, there's this white box with a screen, a TV or something like that on top of it, and a keyboard in front. It was an IBM, or so we called it. It was not necessarily an IBM branded computer, but it was a so-called IBM PC clone. A very unusual sight in Poland back then, and actually all around the world back then. And I managed to sit in front of that computer when no one was looking, and I started typing on the keyboard. And I'd like to believe I pressed enter. I'm not sure. I probably didn't even know what that particular key on the keyboard meant. Anyways, my parents managed to drag me away from the computer the moment they saw me there, but it was too late. I was already hooked, and I still am. Fantastic memory. Clearly, a core memory has formed. There was back more than what 40 years ago. It's scary to think about it. Um, why? How could this happen? This was in mid 80s. In August 1981, IBM, after creating the personal computer the way we know it right now, uh, those machines were using microprocessors called 8086, 8088. These were processors from Intel. We would call them IBM PC XT. IBM saw that these machines had potential to pretty much spread around the world and be used globally. But also IBM really realized that they were probably not able to build enough of those machines to make an impact in the world the way that they were seeing it. So what did they do? Something that was considered crazy back then. In August 1981, they released all the specifications of IBM PC. Pretty much every single diagram, every single specification, how to build those machines. There was just one tiny piece of software, BIOS, which kind of helps the machine start up the moment you press the power button that they wanted to keep to themselves. That was so-called reverse engineered by other companies later on. The point is, they made everything available and they effectively created a new market, a market of PC clones. All those PCs that run Windows, that run those window operating systems that you use, uh, they exist because IBM back in 1981 made that decision to release the specification. Not the only time in the IT history, computer science history, or information technology history that a company would do something like this. There were other standards that were made available to others. Some examples are Android, which pretty much helped um, grow a massive chunk of mobile phone market. TCP/IP, the protocol that controls all of the traffic on the internet, that's an open protocol introduced as a mandatory protocol on the internet in 1981. HTTP, Hypertext Transfer Protocol, the thing, the standard that lets browsers access resources on the internet and pretty much made World Wide Web possible. USB Bluetooth, Wi-Fi. You get the point. When you open a protocol, when you make it available to others, it has a potential of really transforming the entire industry. It does not always happen like that. Back in I think 2014, maybe it was 2015, Tesla released all of their patents, all of their standards that they were using to build the cars and the infrastructure around them. These were not picked up by others for all sorts of reasons. These were not really neutral. Tesla had too many sort of hidden or strings attached to those patents when they released them. But in principle, we have a lot of examples like that when a company that is relatively successful releases a standard and grows the market. It allows the company itself to grow, but it also allows the entire market to grow. In 2024, in November 2024, Anthropic released a protocol called Model Context Protocol, MCP. You might have read about it in some of my newsletters. Perhaps I mentioned that protocol in some of the podcasts as well. MCP, Model Context Protocol, allows chatbots, large language models, but in principle chatbots, to access external systems, access external resources. So imagine a chatbot realizes that in order to respond to a particular prompt, it doesn't have all the information. It needs to check the outside world. This is where MCP allows those chatbots to communicate with the external world, if you will. A specific example would be if you wanted to buy a t-shirt using a chatbot. The chatbot obviously needs to contact another or an online store. It needs to see what the inventory is. It needs to get back to you and say, hey, here are the t-shirts that are available. Would you like any of those? Then you would say, I like this one. Then the chatbot would again connect to the online store to check for the sizes available, prices available, and so on. And that communication would continue until you buy the t-shirt. Uh, but it's only possible in two ways. One is when the creators of a chatbot pretty much uh, write a um, a method, a piece of code that allows that chatbot to connect to the web page, get all the information that it needs, and so on and so on. And we've been doing things like this for the past few years. It will be almost, it's sometimes called scraping. It would be a very, very custom way of communicating with the web page. Uh, or, and this is the second way out of the two ways that I mentioned that exist, the chatbot could implement a protocol, a standard for communicating with web pages, and that particular website or web page would also have to implement that way of communicating. If the two of them do that, it's as if they were speaking the same language. Now they can communicate. You don't have to really hack into or hack that connection. You can have two systems that communicate in the same language. Why is it really compelling to do it this way? That's because if you agree on one language to communicate between systems, then you simply make sure that your system speaks that language. And then you know that every other system will be able to talk to your system. You'll be able to talk to the other systems as well. Model Context Protocol since November 2024 has been increasing in popularity. And that's why I have been talking about MCP, because it seems like this is a protocol that will be the standard way of communicating between chatbots and external systems. Why does it matter? Because if you have an online store, if you have a bank, if you have an entity that needs to communicate with customers, with humans, and you currently have web channels or maybe mobile apps that allow them to communicate with you, you need to consider the fact that some of your human customers, some of them will start using chatbots or are already using chatbots, and they will ask themselves, hey, could I communicate with my service provider, with the company that I want to work with through a chatbot? This is where, if you're a bank, if you're a university, if you're another type of business that communicates like this, you need to consider, hey, maybe I should have a channel for chatbots so that when my customers go to, I don't know, ChatGPT, Claude, whatever, and they say, hey, check my account balances in my bank, you would be able to respond to that, right? All the cybersecurity people are worried at the moment. What does it mean? But look, the reality is this is just another channel that we need to figure out how to create for our customers. Grasshopper Bank is the first bank in the US that implemented MCP. Their customers can check their account balances just by chatting with a chatbot. The chatbot will check those balances on their behalf and then respond to the customers. Figma, a digital design company, now has a so-called MCP server, so a way for chatbots to communicate with Figma. So then you can ask a chatbot to create a design for you, and it will use Figma to do that design. So that's what it works. Now, Model Context Protocol is an open protocol, so anyone can implement it at the moment. But until last week, 9th of December, I'll get back to the date, it was open, but it was owned by Anthropic, the makers of Claude, the creators of the protocol. What does it mean? If you're OpenAI, Microsoft, Google, or any business really, you would hesitate a bit to implement this protocol, because what if it changes in a way you don't want it to change? What if something dramatically changes and you're caught in this situation where you've invested so much into the protocol, but now you cannot move back? This was a problem, but on the 9th of December, Linux Foundation, the foundation that governs the biggest open operating system that we have here in the world, created an agentic AI foundation. It's their initiative where they brought a couple dozens companies, if not more, who decided to work together on this open community governance of agentic AI protocols. And three protocols or three standards were donated to that foundation. Model Context Protocol, which I talked about a lot already. Goose, which is a protocol, an environment for running agents that is created by Block, a company called Block, and also agents.md, which is a file that describes how agents should behave, that was donated by OpenAI. Each of those are specifications or standards that are now governed by a community. Uh, this is really important because now it's much safer to commit to Model Context Protocol, because you know that it'll be developed and managed and governed by a community. So all those large organizations will likely really properly commit to it. So what, you might be asking? Well, this is why we're talking. This is why I'm sharing all this information. Look, of course it's impossible to predict the future, but I'm trying to point you in some interesting directions, and I think this might be developing into something really interesting. I'm not telling you to implement Model Context Protocol today, although if you're adventurous, go ahead, talk to your IT people and say, hey, can we have an MCP channel for our customers? But at least pay attention to it, because it looks like this market will grow, just like, HTTP, HTTPS later on created this potential for the World Wide Web. So perhaps, that B2A to C, business to agent to customer business principle that I write about in The Economy of Algorithms is going to implement it using MCP. So this might be one of those moments that create new markets, that create new players. Remember my visit to my uncle in Poland in gloomy November. That PC was probably a Taiwanese clone of IBM PC. Quite likely, it was a clone created by a company that later would be renamed to Acer, one of the largest computer makers in the world. Back then, they were just a tiny company that tapped into a potential of a standard that just got opened. I think that's pretty interesting, and I think it makes sense to pay a lot of attention to what happens to MCP in the next 12 months or so. Stay curious.